Welcome viewers to yet another video on analytical instrumentation. In the current video, we will be going through the basics of fluorescence and phosphorescence. So before starting with the basics, let us understand some terms. We all know that the electrons present in the atom have a specific spin associated with them. These electrons pair themselves with electrons having spins opposite to theirs. As a result, the net spin of the pair of electrons is 0. When the electrons are paired with electrons having opposite spins, they are said to be in a singlet state. However, certain times arise when both the paired electrons have same spin associated with them. Such a state is called a triplet state. Looking at the energy level diagram, we can try to understand how phosphorescence and fluorescence are produced. The energy level diagram helps one understand the production of fluorescence or phosphorescence. As seen in the diagram, there are different energy states. In the ground state of molecules, the molecular energies are constant and possess minimum value. When external radiations or EMR fall on the molecule, it absorbs the energy from external EMR. Due to this absorption, an electronic transition takes place, and molecules transition to higher electronic states like second electronic singlet state or first electronic singlet state as depicted in the diagram. It should be noted that electronic transitions will occur only for specific molecules and only when bombarded with specific wavelengths of EMR. This is because only radiation of a specific wavelength and energy is absorbed by a characteristic structure. As seen in the diagram, lambda 1 refers to the wavelength of light absorbed by the molecules to transition to first electronic singlet state. The excited singlet state remains for certain time, its order being 10 to the power minus 8 to 10 to the power minus 4 seconds. After this short time interval, the electrons return back to the ground singlet state. During this transition, energy is released in the form of emissions. This phenomenon is called fluorescence. This transition involves less energy than the original absorption. So, the emitted wavelength is greater than the absorption wavelength. That is, lambda 3 is greater than lambda 1. One can perform both qualitative and quantitative analysis of a sample by studying and measuring its fluorescence. Sometimes, electrons, instead of transitioning from first electronic singlet state to ground state, go to first excited triplet state. They stay there for some time before transitioning to the ground singlet state. This transition is accompanied by emissions being released. This phenomena is called phosphorescence. Even phosphorescence helps one perform analysis of an analyte. Fluorescence is immediate emissions of absorbed radiations, whereas phosphorescence is delayed release of absorbed EMR. Now let us try to understand the principle of fluorescence measurement. Again, we can refer to the diagram shown here. As seen, the detector is placed perpendicular to the light path of emitted source. The analyte is placed in the cuvette. These instruments are employed with multiple filters or monochromators. One filter is placed between light source and analyte. This filter helps to achieve a good monochromatic beam of a particular wavelength that would be absorbed by the analyte. The second filter is placed between the analyte and the detector. This filters out the phosphorescence radiations from the stray light, and only fluorescence is measured. That's it for the current video. Hope you have learned the basics about fluorescence and phosphorescence. In the next video, we will talk about the instrument that is used to measure fluorescence, that is the spectrophlorimeter. Till then, stay calm and keep learning. Peace out.